Fourth problem. The resistivity of copper is 1.724 micro-ohm centimeter at 20 degrees Celsius. Determine for copper at the same temperature the resistance of A between opposite faces of an inch cube, B of a wire 1 foot long and 0.001 inch in diameter, C of a rod 1 meter long and having a diameter of 1.0 mm. Okay, so let's start with the problem letter A. So for problem letter A, let's check the given parameters. For A, an inch cube with a width of 1 inch and the length of 1 inch. To get the cross-sectional area of a inch cube, you have to multiply the length and the width, which is equal to 1 square inch. And for the resistance of R unknown. So solving for our resistance, we need to use our formula. The resistivity for our inch cube is already given, that is 1.724 micro-ohm centimeter. So using our formula for resistance, that is R is equal to resistivity length over the cross-sectional area. So we have a given value for our resistivity, that is 1.724 micro-ohm centimeter. About for our length, we have 1 inch. 1 inch. Since the unit for our resistivity is in centimeter, we need to convert 1 inch to centimeter. So in every inch, there are 2.54 centimeter. Okay, all over the value of our cross-sectional area that is already in the figure, that is 1 square inch. Again, the unit of our resistivity is in centimeter. So we need to convert inch to centimeter. That is 2.54 centimeter all over 1 inch squared. So since squared. So okay, we cancel out some common units. So the inch is converted to centimeter. This will become, the remaining unit here is micro-ohm square centimeter. About in the denominator, we cancel out square inch and the remaining unit is square centimeter. Okay, so solving for your R, your R here is 0.6787401.575. So the remaining unit is in micro ohms. To recall, our unit here will become square centimeter. It will be cancelled out since the remaining unit at denominator is cubic centimeter. So our unit here is, the remaining is micro ohm square centimeter. So our square centimeter will be cancelled out and the remaining units is in micro ohms. So that is the value for our resistance for our A. the resistance between opposite faces of an inch cube. How about for B? Resistance of wire 1 foot long. So we have a wire 1 foot long. So for our wire, we have 1 foot long. So we need to solve for the resistance again. Okay, but the unit for our diameter is in inch and the unit of our length is in feet. So if the diameter here is in inch, we can use the conversion of our inch to circular mil. Okay, so doing so, if the diameter is d squared, if the cross-sectional area of the cylinder is d squared and the unit is mil, so we need to convert this inch to mil. So our diameter is 0.001 inch. So we use this conversion. So in every inch there are 1,000 mil. So we cancel out inch, the remaining is 1 mil. So 1 mil. Since the cross-sectional area is equal to the d squared, therefore 1 mil squared, finally our cross-sectional area is equal to 1 circular mil. Okay, so going back to our equation, we have our cross-sectional area, the length, we can substitute it right away to our formula for resistance. So, okay, so the resistivity of our conductor in ohm circular mil foot, we need to input the value of 10.37 ohm circular mil per foot. So how about the length? That is 1 foot all over the cross-sectional area of 1 circular mil. So if we cancel out common units, so we cancel out circular mil, feet. So finally, the value of our resistance is 10.37 ohms. So that is your answer for letter B, and this is for our letter A. How about for C? So for C, we need to determine the resistance of a rod 1 meter long and having a diameter of 1 mm. So if we have a rod, one diameter of 1 mm and a length of 1 meter, we need to determine the resistance. Okay, so if this is a rod in nm, so we can use our conversion in our for our cross-sectional area from this 1/4 pi d squared. So solving for your r using our same resistivity, r, the resistivity of 1.724 micro-ohm centimeter. So how about for our length? That is 1 meter. So we need to convert, since this is in centimeter, we need to convert 1 meter to centimeter. So in every meter, there are 100 centimeter. Okay, all over the cross-sectional area. So since it's a cylinder, we need to use our formula for our cross-sectional area, that is 1/4 pi d squared. So what is our diameter? That is in 1 mm. So since the unit are centimeter, we need to convert mm to centimeter. Okay, so in every mm, there are zero point 0.1 centimeter. So this is RD, so that is in squared. So we cancel out common units. Here we convert meter to centimeter, we cancel meter. The remaining unit is in centimeter. So micro-ohm centimeter centimeter, that will become micro-ohm square centimeter. In the denominator, we cancel out millimeter, we cancel out millimeter. The remaining unit is centimeter. Power, so that is square centimeter. So both numerator with square centimeter will be cancelled out. So the remaining unit is in micro ohms. So finally, solving for your R, your R is equal to 21,950.64975 micro ohms. So that is your answer for your letter C. Okay, let's take a review. So the problem in letter A, face of a cube. Resistance between face of a cube. So we determine by using the length and the width to determine the cross-sectional area of our cube. So we have 1-inch cube. So using the formula for resistance is equal to resistivity, length all over the cross-sectional area, and we use the standard resistivity for copper, which is also given in our problem, 1.724 micro-ohm centimeter. Since the length is in inches, we need to convert it to centimeter. Using the conversion, in every inch, there are 2.54 centimeter. All over the cross-sectional area. So the cross-sectional area, we determine it from our face of a cube. So we have a cross-sectional area of 1 square inch. So since the unit of resistivity is in centimeter, we need to convert inch to centimeter. So in every inch are 2.54 centimeter and to the second power. So we cancel out both inch, and the remaining is square centimeter at the denominator, at the numerator is square centimeter. So we cancel out. The remaining unit is in micro ohms. So finally, our answer for our letter A, the resistance between opposite faces of an inch cube is R is equal to 0.6787401.575 micro ohms. For your letter B, so the resistance between the wire 1 foot long and a 0.001 inch in diameter. So here, the unit of our conductor is in inch and foot. So we need to use conversion, since we're going to use the standard resistivity here of 10.37 ohm circular mil foot. So the diameter 0.001 inch, we convert it into mil. So in every inch, there are 1,000 mil. So we cancel out inch. So the remaining unit is 1 mil. So from 0.001 times 1,000, that is 1 mil. So since the formula for the cross-sectional area of a conductor is equal to d squared, so we substitute 1 mil to d squared. If square of a mil that is your 1 circular mil, so that will be your cross-sectional area. So solving for your R, we use the resistivity 10.37 ohm circular mil foot times the length of a conductor, this 1 foot, and all over the cross-sectional area of 1 circular mil. So we cancel out foot, both feet, and the circular mil, and the remaining unit is in ohms. So finally, the resistance of our B in a 1 foot wire long 0.01 inch diameter, that is 10.37 ohms. For letter C, the resistance of of a rod 1 meter long having a diameter of 1 mm. So we use the same resistivity 1.724 micro-ohm centimeter. Since the length is in meter, so we convert meter to centimeter so we can cancel out centimeter. So at the cross-sectional area, we use the cross-sectional area of a cylinder which is equal to 1/4 pi times d squared. Our diameter is 1 mm. So we need to convert millimeter to centimeter. So we cancel out millimeter, the remaining unit is square centimeter. At the numerator, we have the remaining unit is micro-ohm square centimeter. So we cancel out square centimeter, numerator, and denominator. The remaining unit is micro-ohms. Doing the math, the resistance is equal to 21,950.6497 micro-ohms. Okay?